or force on. Okay. Now, how many of you go to get a shopping cart and you pull it out, you're like, nope, and you get another one? Right?
The wheels
Why?
are messed up.
The wheels are messed up. So there's hair wrapped around the axle, or there's bubble gum on the wheel and it like slides, it doesn't roll, right? There's something wrong with the shopping cart, so you go back and get a different one. At some point, you're gonna select a shopping cart with an acceptable level of what? Rolling friction. You're going to pick a shopping cart. You're going to say, I'll deal with this one. It's not perfect, but at least the rolling resistance, the rolling friction is even, and I can handle it. And then sometimes there'll be only one cart left, and it's one that goes cluck, 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 cluck on one side, right? You know what I'm talking about? Okay, anyway. You have to exert some sort of force to overcome. If it's sitting still, you're overcoming what type of friction?
Rolling friction.
Rolling is once it's moving. If something is sitting still, we say it's static. Static, like if something is on a static display, that means it's just there to look at, right? So you've got to exert enough force to get it moving. All right, cool. That's the answer. Moving on. 282. Click the next button to get the next page. It's the picture, page that has a picture of the boxes with the arrows. The arrows that are bigger means there's more force. The arrows that are smaller means there's less force. Okay? Number 1, infer. Doesn't have anything to do with the boxes here. Infer somebody's pushing on a door from one side, and then somebody else is pushing on the other side of the door with the exact same force. The door ain't going to move. Everybody got that one, right? The door won't do anything if the exact same force is being applied to both sides of the door. Now, what if the force was closer to the hinge on one side than the other? Then you could be able to have some movement, right? But if it's applied the same way on both sides, same amount, nothing. Good. I overthink things sometimes. Always. Number 2, identify. Look at the box with unbalanced forces. It says unbalanced right underneath it, so you know which one you're looking at. In which direction is the strongest force, to the right or to the left? Which arrow is bigger? So it's actually pointing to the right. The force on the left being applied towards the right is bigger, which means the motion which would be in what direction? To the right. But that's not the song, is it? Isn't the song to the left, to the left? Is that Beyonce? Who is it? Rihanna? To the left, to the left. Something, something, to the left.
Oh, wait, I thought you
What? Who sings that? That is way older than you all. Okay, showing my age. And that's way younger than me, so it's really cool. Here we go. We are on the next page, 283. The one that has Newton's first law of motion and friction, and what is static friction? Are you okay?
Yeah.
Are you going to be able to control your mouth?
Yeah.
Okay, thank you. If you could. Infer. Think about Newton's first law. What would happen to a moving object if there were no friction? So an object is moving, and no friction is affecting it. What is it going to do? It's going to keep moving. So, first law, an object in motion will stay in motion unless acted upon by an unbalanced force. Okay? Cool. Next page, 284. Explain. If a wheel is rolling forward, what type of friction pushes the wheel forward? Remember, I told you that was a garbage question. It's a really bad typo, or they just really don't understand what they're talking about. The rolling friction is going to resist movement. Yes? So, and that is the answer they were looking for. Rolling friction. They just describe it really, really weird. All right. End of section question. Zzz. There's 3 of them. The first 2 are required, yes? The third is only if you did the flashcards and want to do the question. Okay? First one says, review the terms. When you push a skateboard on a flat surface, why does it stop after a while? Use at least one term from that mini glossary in your answer. Okay, whether the skateboard has a person on it or not, once it's going, if it's on a flat surface, eventually it's going to stop. Why? Due to what type of friction specifically? Somebody else said it. Can you repeat it? Rolling friction. Okay, good. So imagine you bought a cool skateboard, but you didn't want to buy like a top-of-the-line skateboard. Maybe you were really on a budget and you bought the cheapest one you could find and you turn it over on the back, it says made in China. I'm gonna get canceled in China for that one. That's okay. Has anybody ever had a skateboard or roller skates or anything with little wheels that start to waller about? I mean, the wheel gets really loose as it's rolling. Okay, so what happens there is they've got, if they have ball bearings in there, you know those little BBs that wrap around the axle to keep it rolling nice? Sometimes they put a plastic casing around that. So you've got you've got plastic wheel, plastic axle, and you've got the ball bearings in between. Well, if you're using it hard, shall we say, what can be generated from that rolling friction that you're going to have? Friction creates heat. What's going to happen to that plastic housing? It's going to melt the heck out of it, and now you're going to have a gap, and any lubricating grease they might have had in there is going to be gone, and now you're going to have a pile of junk that you bought for less than what you could have paid for, maybe a little more, for a higher quality skateboard. That's why it's important to look at the reviews. My wife's always telling me, look at the reviews. There's a reason for that. What?
Buy your own bearings.
Buy your own bearings? Well, you'd have to do the whole housing and everything, right? Because the bearings weren't probably what failed. It was probably the plastic around the ball bearings.
Replace the whole wheel.
Just replace the daggone skateboard with one that's not junk. Okay, I'll wait for y'all. This is where I'm going to turn it over to you. You guys ready?
Yeah.
Do you understand what we just did? We went over the margin questions, and we went over the end of section questions from the first section. Okay? I want you all to pair off max group of 3, and I want you to go over section 2, 2 and 3, sections 2 and 3, just the way we went over it as a class with 1 or 2 other people. Don't just say, what'd you get? Why did you or why did we get this answer? Okay, do you see how we kind of talked it through? Talk it through. I'm giving you permission to talk. Go. Yeah. All right. Hey, so I like stories. I like it when people ask practical questions. Dockery asked a practical question. He says, well, if you've got all this heat, rolling friction, either in the bearings or in the rubber of the tire, how many of you guys have ever been driving on the interstate and you've seen maybe a semi or a trailer with the wheels on fire? The rubber is actually on fire, smoking black. Crazy. A couple of you? Couple? Okay. So a car tire, I mean, I'm trying to answer your question. I know I already did, but a car's tire versus a semi's tire, the engineers that are putting together the total package of the vehicle put a lot of thought into it. What carries more weight, a passenger vehicle or a semi-trailer tire? Semi-trailer tire is probably going to have more weight. So in a car tire, you got maybe 30 to 35 pounds per square inch of pressure inflating that tire. A semi has like 90 psi in some cases or more of pressure. When they inflate them, they actually have them in cages because if they fail, it could hurt the person inflating them. Does that make sense? So it's much more rigid. So as it's rolling down the road with a load, there's less flexing of that rubber, so it's generating less heat. Also, when you do see occasionally tires catch fire, it's not because of that usually. That would probably cause a blowout instead. When they catch fire, it's because the brakes have failed. So if the drum brakes or disc brakes or whatever they've got in there, if they clamp shut and they're just producing heat because the driver doesn't realize, or they're just like, for some reason I'm not going, so they just hammer down the gas, right? And they keep going, the brake hardware, the drums and everything can heat up. Well, what are the brake drums or calipers, rotors, all that attached to? They're attached directly metal to metal with the wheel. and then the rubber of the tire mounts directly to the wheel. So that heat from the malfunctioning brakes will transfer to the rubber, and it can get hot enough that it'll actually start to smoke and catch fire. That's one of the reasons why truck drivers are required to carry the right type of fire extinguisher with them. Make sense? Because it happens. Grams, okay. So what can I fill in? What is kg? What is kilogram? Mass, good. So I can put in my 14, or no, what'd you say, 2 kilograms?
Right there.
2 kilogram mass ball. And mass times what gives us force? We have mass. What's the A? Acceleration. And do we have the force?
Yeah.
Ryan?
Yeah.
What is it?
14.
We're given the force, which is 14 newtons,
Yeah.
also known as kilogram meters per second squared. Yes?
Yes.
So, if we're looking for variable A, what do I need to do to it? Starts with an I, mathematics. I'm looking for a variable. I have the other two. I need to get it by itself. It starts with an I. I need to isolate the variable. So how do I get this 2 kilograms? How do I get this over there? Divide 14 by 2, right? And I'm also going to divide 2 by 2. Yes? To get it off that side. So I'm going to do it to both sides here. 2 kilograms and 2 kilograms. What is 14 divided by 2? 7 equals acceleration. 7 what equals acceleration? What is acceleration always measured in when we're using this formula? Meters per second squared. So it's going to be 7 meters per second squared. That's it. Does that make sense?
Yeah.
How do we check our answer? Plug it in, make sure it's true. Is 2 times 7 14?
Yes.
There you go. Everybody good on that one? Awesome. Any others you have a question on? Is everybody